So looking at difference of squares, if you remember from foiling in the beginning of the chapter, oh my gosh, that was the same chapter that we're currently in. Yep. When we foiled a plus b times the group a minus b, that was one of our special products, we said that that was equal to a squared minus b squared. Now that we're factoring, we're taking that and going backwards. So we can now see a squared minus b squared. Notice that it is a difference, subtraction, of two squareds, and factor it as a plus b times a minus b. We've seen some of this in the activities that we've been doing, and now we're kind of officially getting to it. So if we see that x squared minus 25, we can see that as x plus 5 times the group x minus 5, because x squared is the square of x times x, 25 is the square of 5 times 5, we can see that as x squared minus 5 squared, so x plus 5 times x minus 5. So if we see 16y squared minus 81z squared, think that 16y squared is 4y squared minus 81z squared is 9z squared. So we can say that that's 4y plus 9z times the group 4y minus 9z. And there we go. We factored it. Easy as that. Now, sometimes we might have to use difference of squares multiple times. So if we have n to the fourth minus 625, think that n to the fourth is n squared squared minus 625, which turns out to be 25 squared. So we can say this as n squared plus 25 times the group n squared minus 25. Now, here's where we need to start thinking critically. Are we done? Is there any more factoring we could do? If there is not any more factoring we could do, great. But there is. N squared plus 25, sum of squares don't exist. I repeat, sum of squares do not exist. Now, n squared minus 25, that's a difference of squares in itself. In fact, we did it earlier. So we have n squared plus 25 times the group now n plus 5 times the group n minus 5. Do you really have to go that far? Yes. Because again, your directions are just going to say factor completely. Is this factored completely? No. We can go one step further and say n squared plus 25 times n plus 5 times n minus 5. Now, you might be presented with an issue, not an issue, an opportunity, where you get to use as many factoring techniques as you can. So, look at this, 6x cubed plus 30x squared minus 24x minus 120. First step in factoring, is there a greatest common factor? 6, 30, negative 24, negative 120, 6x cubed plus 30x squared minus 24x minus 120. Yes, and it's 6. 6. So now we have 6 times x cubed plus 5x squared minus 4x minus 120 divided by 6. Just double checking, don't want to lead you astray. That's right, minus 20. Now, we have 4 terms. Do we see a difference of squares right away? No. We can't really do anything with other factoring because we have 4 terms, but remember in 4 terms we can use grouping. So we can say the group x cubed plus 5x squared plus the group negative 4x minus 20. So x squared plus 5, or x cubed plus 5x squared, I can pull out an x squared and be left with x plus 5. Plus negative 4x minus 20, I can pull out minus 4 and be left with, again, x plus 5. Now, I have 6 times the group x plus 5 times the group x squared minus 4. Are we done? Not quite. I see a difference of squares, x squared minus 4. So that x squared minus 4 is x squared minus 2 squared. So I can rewrite now 6 times the group x plus 5 times x plus 2 times x minus 2. Again, remember we need to factor completely, using all of the techniques. We use greatest common factor, grouping, and difference of square all in one, and that's okay. Our practice problems are on page 1213, numbers 15 through 42, multiples of 3. 15 starts out with a pretty simple one. We have q squared minus 121. Remember, 121 is really 11 squared. So then we have q plus 11 times the group q minus 11. Now, as you go, you're going to have to use more and more factoring techniques. What factoring techniques do we know? We know greatest common factor. We know grouping. We know what to do when we have x squared plus bx plus c. We know what to do when we have ax squared plus bx plus c. We also now know what to do when we have a difference of squares. So you're probably going to have to use all of these techniques tonight. And you know what? It's good for you.